This is an application problem from chapter 2.2. We have a restaurant that purchased some kitchen equipment on January of 2017, and then 2 years later we have a book value for that kitchen equipment at $14,650. The function given is modeling the value of that kitchen equipment as a function of time, and perhaps it's not as clear as it should be. The t there is beginning in 2019. We know that because the form of this function, this is an exponential growth function here. We've got the, well, the function's name is v. It's a function of time. And we've got this initial value. This is the coefficient of your exponential piece. And this can be thought of as the initial value. And as you notice, that's the value in 2019. So t equals 0 is associated with the year 2019. And the growth rate is negative. Probably makes sense. The kitchen equipment is probably going to lose value over time. And specifically, the growth rate is negative 15.3%. So this is the function. And part one, or A, wants us to find the rate of change in the value of this equipment on January 1st, 2019. So right away, we might even just consider the fact that, hey, t looks to be defined as the number of years since 2019. So January 1st, 2019. So t equals 0 is the value of t that would be associated with that date. Now they want us to find the rate of change. So immediately you should think derivative. The derivative is a function for the rate of change for any value of the input that we care about. For the function given. So we have this function that gives us the value of the kitchen equipment. If we get the derivative, it'll give us a means to find the rate of change in this value for any value of t, specifically t equals 0, because that's the t equals 0 is associated with January 1st, 2019. So to get the derivative for these exponential functions, all you got to do is rewrite them. So this is $14,650 e to the negative 0.153. This is itself the value of the equipment at time t. The rate of change is negative 0.153. And if I find 15.3% of whatever the function's value is at a particular point, I'm going to get the rate of change. So what do? We just rewrote the function and then multiplied by the coefficient of the exponent, the derivative of the exponent, in this case, same thing. So this is the derivative. For all these exponential functions in chapter 2, I'm assuming it's base e, most of them are, that's what you got to do to get the derivative. You just simply rewrite it and then multiply by, again, the coefficient of the exponent. So we've got the derivative, and then specifically we want to know what's the rate of change January 1st, 2019. So that's t equals 0. So if I make t equals 0, you can put this in a calculator. You could I guess that's the best way to do it here. Right, now if I make t 0, I'm just going to get this 14,650. So, I mean, you could also put the e in there, but I know that this, if I'm plugging in 0, I'm just going to get this piece here. So I can multiply that by negative 0.153. Just so that's clear, right? You could write the whole thing, 650. I could even do the e to the negative 0.153, put the 0 in there for t, times negative 0.153. Get the same output. Right, so this is the rate of change in the value of this kitchen equipment at specifically t equals 0, which is January 1st, 2019. So this should be the answer. This will be dollars per year. So at this particular point in time, the value of this kitchen equipment is changing, or it's losing roughly $2,200–$2,300 per year at that point. So again, that's the answer for part A. Part B wants to know what's the original value of the equipment. This question is a little confusing because we think of the coefficient of the function here to be the initial value. In this case, it's the initial value as t is defined. It looks like t is being defined as the years after 2019. So while it's not necessarily the initial value as far as the purchase price of the equipment, it's the initial value when the value of the equipment began to be modeled. So the way to get this here is to Well, there's perhaps a couple of things you could do. I think probably the most straightforward is to just simply, well, if I'm looking to get the value in January 1st, 2017, that's 2 years prior to t equals 0. Well, I can just plug in t equals -2. That's probably the smartest way to do it. Just make sure that we plug this into the original function because it's the original function that gives the value at time t. The derivative is giving the rate of change in the value. So we're going to do 14,000, missed a 5 here, 14,650 e to the negative 0.153 times -2. I could actually just put that in the calculator here. So it's 14,650 base e negative 0.153 times -2. And notice that's higher than what we had, so that makes sense, right? When the purchase prices should be higher than its value 2 years later, considering this should be a depreciating asset, it's kitchen equipment, so lose value over time. So this answer makes sense. $19,894. We'll make sure we would round that accordingly. It's likely to ask for the nearest dollar. But hopefully you found that helpful, and thanks for the question. Bye.